Here we're going to look at question 32 from section 1 of the ECAA 2018 paper. So in this question we're told that we have the curve y equals x squared minus 9 and we have two tangents drawn to the curve at y equals 0 with the point where the curve intercepts the x-axis. So what the question asks us to do with this information is to find the area of the closed region bounded between the curve and these two tangents. Now if you'd like to have a go at this question yourself, then please pause the video now, otherwise let's have a go at it. So to go about answering this question, we should probably think about what our area actually looks like and where it is on our diagram, on our graph. And to do that, the first thing we're going to have to do is to draw our curves, to draw our graph. So we can begin by drawing our curve of y equals x squared minus 9. By sticking that on a diagram, it's going to look a bit like this. And then we have to add our tangents. So the tangents are at the points where the curve intercepts the x-axis, so they'll look something like this, meeting at a point on the y-axis down below, since it's going to be symmetrical. So we want to try and find the area bounded by the curve and our tangents. So if we call that area A, then on our diagram it's going to be this area here. And to find that area, what we could do is we could find the area that our tangent makes with the x-axis, and then we could take away the area that the curve makes with the x-axis, like this. So this will be the triangular area and our curved area. So if we try and find our triangular area, then to find the area of a triangle, we're just going to need the width of our triangle and the height of our triangle. So to try and find the width of our triangle, we're going to need our x-intercepts, the point where our curve intercepts the x-axis. So to find this, it's the point at which y is 0. So we can take our equation for our curve and set in y equals 0 and solve for x, which is going to give us these two x-intercepts of minus 3 and plus 3. So we know that the width of our triangle is going to be 6. Now though, to try and find the base of or the height of our triangle, we need to try and find the point at which our tangents intercept the y-axis. So to do this, we need to try and think a bit about our tangents and find out something about them. So we'll notice that they're straight lines, which are tangent to these to the curve, at x is plus 3 and x is minus 3. So what we could do is we could consider the differential of our curve. So why would we do this? Well, since our tangents are straight lines, then they're going to have the equation y equals mx plus 3. So here what we're going to do is we're going to consider this tangent on the right passing through positive 3. And then if we want to find the gradient of this line, then we can use the differential dy by dx and we can evaluate it at the point x equals 3, since this is the point on the curve at which we're finding the tangent. So this is going to give us a gradient of 6. And therefore, the equation for our tangent passing through x equals 3 is going to be y equals 6x plus c, where c is going to be some constant, which is actually going to be the y-intercept. So we need to try and find that somehow. So the way to find this is going to be to sub in some known values for y and x, since then c is going to be the only unknown. The only value which we know that this tangent passes through is the point at which x is 3 and y is 0. So if we do that, then we see that this is going to give us the equation 0 equals 6 times 3 plus c, which of course we can rearrange to give us a c equals minus 18. So that means that the y-intercept c is going to be minus 18, giving us a final graph which looks something like this. So now that we've found out all this information about our graph, we can go ahead and try and find some of our areas. So let's first consider the triangular area, so it's going to be a bit easier since it's a nice even shape. So as we already said, to find the area of a triangle, we just do the half multiplied by the base of the triangle multiplied by the height. So here the base is just going to be 6, since it goes from minus 3 to 3, and the height is just going to be our 18. So the area under this triangle we can just find by doing this calculation to get an area of 54 units squared. So now all that's left to do is to find the area underneath our curve. So how could we do this? Well, since we're trying to find the area underneath a curve, which we have the equation for, then all we could do is we could do some integration. So the integral to find the area under the curve between x equals minus 3 and 3 is going to be this. which we can of course then solve by integrating the expression inside our integral, and then subbing in our limits of 3 and minus 3, which after doing all of that should finally give you an answer of minus 36 units squared. Now at this point you might think it's a bit odd because our answer is going to be negative, but the reason it's going to be negative is because we're finding an area which is below the x-axis. So generally with integrals this area is defined as always being negative, which is just why we have a minus 36 here instead of a positive value. Now with this information we can go ahead and actually calculate our area A by just taking our triangular area and minusing the area underneath our curve, 36, or the magnitude of the area underneath the curve at least, which is our 36 units squared, to give us a final answer of 18 units squared, which is going to correspond to answer B given in the question.